So in this video, we're going to have a quick review on how to solve 1- and 2-step equations, along with some important vocabulary, including constants, coefficients, terms, and what to do about denominators and coefficients that are fractions. So what I've got here is I've just got several examples of equations that are solved with the work shown, and I wanted to just use these problems to remind you guys of a lot of the stuff that you probably learned in elementary school. This might be a little bit of a review in terms of how to show the work, but please make sure that you're paying careful attention with the vocabulary and kind of the entire purpose of some of the stuff that we're doing, okay? So for the first one we have m plus 7 equals 29. In this situation, the coefficient of our variable is already a 1, so we don't need to worry about that. The only thing we're going to need to do to solve this equation is to cancel out the constant. Now currently, since it's a positive 7, we want to subtract 7 on both sides. We have 7 minus 7 will equal 0. That's the inverse property of addition. That's why we choose a negative 7 here. Friendly reminder that we have the subtraction property of equality that says what we do on one side, we do on the other. So don't forget about your properties of equality here when solving the equations, okay? And so on this side, it'll be m plus 0, and we don't have to write the 0 because the identity property. And so then we just have 29 minus 7, and we get 22. So this is just a nice, easy one-step equation where you just have to subtract to get rid of the constant. Now in the one right next to it, we have 8 subtract y. And in this situation, folks, we have a negative 1 as our coefficient. So the first thing we're going to do is recognize that we have a positive 8. 8 minus 8 cancels out to be 0, and we subtract 8 on this side to get 2. We can't forget about this negative 1 that we still have with the y, though, so we're going to divide both sides by this negative 1. A negative 1 divided by negative 1 is now a coefficient of positive 1, and that's always our goal. And so over here, when we do the 2 divided by the negative 1, we're going to get a negative 2. Now to check this one, if we get a negative 2, friendly reminder that when you plug it in, you've got 8 minus, and now we're saying negative 2 is our answer. So that would turn into addition, 8 plus 2, and that's a 10, and that is the total that we wanted right there. Now in the next one, this 4 is something called a coefficient. It's multiplying by our variable h. So 4 times some number equals negative 16, and so to find that number, we just need to divide 4 by itself. 4 divided by 4 is 1, so we've got h alone over here. And then the 16 that's negative divided by 4 gives us a negative 4. And you can check by just saying 4 times negative 4 is, of course, negative 16. Now these problems are relatively easy. These are things that you can do in your head, but the goal here is to review how to show the work and why we're doing certain things here. In the next one, our coefficient can absolutely be a decimal, so we're just going to divide both sides by that decimal. And when you take a calculator and use 4.9 divided by 0.7, you'll get 7. And in the last example over here on the top row, we have a 5 plus j. And so since 5 is a constant that's positive, we're going to subtract 5 on both sides. That cancels out over here. J is left alone. And 25 that's negative. When you take away 5, that's going to be 30 negative. Okay? Now, very careful with this next one. A lot of people here are going to get something like this incorrect. When you see the 1/2 q, a lot of people, when they see half q in the 20, they're going to think the answer here is 10. But it's half of some number is 20. So to figure out what that number is, if we want this to be a coefficient of 1, off to the side, I'm going to just ask you guys, what do you have to multiply 1/2 by to make it a 1? So that's why you see that we multiply by the reciprocal, and that should look familiar. That's the inverse property of multiplication. That equals a 1. So now when you multiply by the reciprocal, you get your 1q, and of course you don't have to write the 1 because of the identity property. And then on the other side, the 20 times the 2 is 40. And so to check, when you take half of 40, that is 20. So that's what you see here. You see me multiplying both sides by the reciprocal when your coefficient is a fraction. Now for the next one, on the computer, it might look like y divided by negative 8 with this backslash. However, it's y over negative 8, up and down. Some of you are used to seeing it like that. And so this time we have that some number, when divided by negative 8, gives us 4. So the opposite of that is to multiply. And on this side, when you see me multiplying by negative 8, technically that's over 1. And so this negative 8 and negative 8 cancel out, and y over 1 is just y. And so for this one, we just multiplied both sides by the denominator, and 4 times negative 8 is negative 32. And of course, to check, you've got your negative 32 divided by negative 8, and that is a positive 4. For the next one here, we've got another coefficient that's a fraction, so we've got a 3/5 x. And so when you take the 3/5, if the goal is to make this a 1, you're going to multiply by 5 over 3. And so over here, you multiply by 5/3. You've got a couple of different options here to multiply that. I personally do 9 divided by 3 to get 3, and then times 5 is 15. But you could, of course, do 9 times 5 is 45, and then divide it by 3. Either way, we're going to get a 15. All right, and on our last one here, the coefficient, we have a negative 2/3 of f. And so since that is a coefficient, that's a fraction, once again, you're going to multiply by its reciprocal. So we multiply here on both sides by the negative 3/2. And when we do that here, you've got your negative times negative, so this is going to be a positive answer. You could do 16 times 3 is 48, then divide it by 2. Or you can do the 16 divided by 2, which is 8, and then times 3. So to kind of sum up here, in solving these one-step equations, if there was a positive constant, all you had to do was subtract on both sides. So like in this situation, the first one, m plus 7, we just subtracted on both sides. If there was a negative constant, then you would add on both sides. So here's an example. If you saw x minus 3 equals 5, since that's a negative constant, negative 3, you would add it on both sides. If there is a coefficient, we talked about this one, you would divide both sides by the coefficient because you want the coefficient to be 1, so anything divided by itself is 1. And last but not least here, if there is a denominator, you multiply on both sides. And that's like the example of the y over negative 8. The last thing we talked about up here was that if there was a fraction for your coefficient, then you just multiply both sides by the reciprocal because the goal is to make the coefficient a 1. All right, so now we've got a scenario here, and we have that a fitness center charges $2 per visit. This kind of sounds familiar, and a $10 monthly fee no matter what. And notice that this time we're given that somebody's total bill was $34. If we've been given the total now, folks, now we're solving an equation for the unknown. So when we have the equation here, that's the $2 each time you go, plus a $10 fee no matter what, equals the $34 total. And what you might remember from our functions unit is that we subtracted the monthly fee first to realize it was $24 in visits. And then we divided both sides here by the 2 to figure out that Nolan here in this case would have gone 12 times. So when showing the work, again, you've got the equation from the scenario, and that's part of what we're going to be spending our time doing in this unit, is now taking the real life problems and writing the equations, and then we're just going to solve for the unknown. So you've got the total here. We subtracted to get rid of the constant. Then we divided both sides to get rid of the coefficient. It's now a 1. And on this side, the math arrives at 12 times. All right. We have one more scenario up here to go through. And then you guys are going to get a chance to kind of just practice some of the equations here hidden behind this blue box. And then I'll just delete the blue box so you can kind of see how you did. All right. So for this scenario up top, we have that each year the 7th grade goes on a field trip to the Marine Corps Museum. Last year, the students were split into 8 bus groups, each with 2 parent chaperones. If the buses carried 400 total people on the field trip from Irving, how many 7th graders are on each bus? So if you want to pause the video and try to think this through on your own, go for it. Or you can just kind of let me mention that. So like if we have 8 bus groups, here's the equation. You've got 8 bus groups. And if there's 8 bus groups, each with 2 parent chaperones, that means there's going to be 16 parent chaperones total, because there's 8 groups, each with 2 chaperones, so that's 16 chaperones. And there were 400 people total on the buses. So the first thing you're going to do when solving here is naturally you're going to get rid of the 16 parent chaperones and say, okay, so I've got 8 bus groups with how many kids we don't know. And that's going to be 384 total people because you got rid of the chaperones. That's just 384 kids. Now when you divide it into the 8 bus groups, that's going to be the 48 7th graders that are in each bus group. So it looks like here each bus holds 48 kids, and then you've got the 2 chaperones on each bus, and so it looks like each bus would hold about 50 people total, but it asked us to figure out how many 7th graders are on each bus, and we're good to go with this answer of 48. Okay. Now, the only other thing that I need to mention here for you guys when solving these 2-step equations is that you're going to now have a constant and a coefficient, or a constant and a denominator. So over here with these problems, all you had to do was one thing to get rid of them, and now you're going to have to do 2 things. So here, for example, try not to look at all of them. For some of them, you're going to have to do 2 things. Here's what I mean. For the first one, we've got the 4x plus 3 equals 27. So on this side, your constant's a positive 3, so you're going to subtract the 3 on both sides. That's the first step. Then you've got 24 left over here, and your coefficient is 4. So now you're going to divide both sides by the 4, and then you've got that x equals 6. To check, you've got 4 times 6 is 24, and then of course plus 3 is in fact a 27. So what I mean, folks, is that sometimes if you have both a constant and a coefficient, or let me see if I can find another one, if there's like a constant and a denominator. Yeah, for like this one right here, let me highlight it so it stands out. This problem, you have a constant and a denominator. So first you're going to get rid of the constant, and then you're going to multiply on both sides here to get rid of the denominator. So the first thing here, that cancels out, and the negative 34 plus 6 is negative 28. And now to get rid of this negative 4, you're going to multiply both sides by negative 4. And then this side by negative 4. And the negative negative cancels out over here, and so x would be on this side. And then you've got your negative times negative. And then we've got that 28 times 4. That's going to be a 112. So this one should be 112. And then, of course, when you check, you've got your 112 divided by negative 4. And that's going to be negative 28. And then when you subtract 6, it's at negative 34, so you know you're good to go. So if you'd like now, try these other ones. Just go, and I obviously covered them up so that you can just try them. If you need to, I can just, you can rewind the video and go back to where the work was shown. And I'll just also say, if you pause it right now, and then when you unpause it, I'll move the box for you to check, okay? All right, so here's everything for you to check. And the problems down here, like when you get to this step, friendly reminder, you've got your 5/2 that you're going to multiply on both sides. So that cancels out inverse property of multiplication. And then on this side, when you divide it by the 2 first, you're going to get 4. And then times 5 is 20. And then we've got a negative times a positive, so this one's negative 20. We already did this one. For this one, folks, you've got to be real careful here. Your constant's 7, so you're going to subtract 7 on both sides. That cancels out here. But this negative, we can't forget about it. So you've got your negative in the denominator, and you're going to multiply both sides by the negative 3. And we get x equals negative 12 for this one. Let's say you leave x in the numerator that's negative there, and then you have your 3 here. And then there was the 4. I'm coming back from this step right here. I'm just putting an x in the numerator. If you multiply both sides by the 3, you've still got a negative x equals positive 12. And so you'd still have one additional step to divide by the negative 1, but you'd still get negative 12. Okay? So my strategy here, when you see this negative, go ahead and put it with the denominator so that when you multiply both sides, you're already dealing with the negative right there. And then that negative cancels out, and then you are automatically at your answer. And for the last one here, first step is to get rid of the 3. So that cancels out, and then 9 minus 3 is 6. And then right here, because we want this to be a 1, we're going to multiply both sides by the reciprocal of a negative 4/3. So then x would be by itself over here. And for this one, when 6 is divided by 3, we get 2. Times 4 would be 8. And it's a positive times a negative. So this one would be a negative 8. Okay? So that's basically the review on solving 1- and 2-step equations here. It just is a matter of what you're looking at when you see the original equation. In this problem, we only had one term, and the negative 4/5 was a coefficient. So to get rid of it, we only had one step. Same with the one right next to it. We had a negative 2 that was a denominator. So to get rid of it, we only had one step. But down in this bottom row, you saw things that required 2 steps along with these first 2 problems. All right. Now, when you flip over, you're going to notice that there's just a review here on combining like terms. And there's a chart here to review that, like, when you have multiple variables, you do it alphabetically. And if you have more than one exponent, it's highest to lowest. So pause the video and make sure you're good to go with combining like terms here. And then you'll see that in these next 2 examples, all you've got to do first is combine like terms, and then you're ready to solve. So you've got your 4x's here, your negative 12x's, and 6x, and that combines here. And then you've got a negative 17 plus 19, and that combines here. And now you're ready to solve this equation, all right? And so that's what you're going to be doing now that the video's over. You're working on finishing up this page. All right, thank you.